Okay, so today's lecture is from Chapter 1, um, from Statistics for People Who Think They Hate Statistics using R. We're going to be starting off, at least with this chapter, with a lot more kind of concepts and content, kind of a basic sort of overview of statistics and some of the basics there. Um, just kind of a quick history and a few things to know. Um, the first set of data pertaining to populations was collected during the 17th century. This was the first time that data was actually collected and systematized in ways that could actually be understandable. And then because of that, the need arose to develop specific tools to help answer different questions. And because of that, this led to the development of different sorts of statistical procedures in several different fields, such as agriculture, astronomy, and politics. So, the agriculture, it was things like how well do different plants do in different types of climates or at different times of the year. Politics, obviously, polling became very popular. And this is kind of where the start of statistics and using statistics to help us understand our world really started. So here's the basic definition of statistics that you really need to know. Statistics is a set of tools and techniques used for describing, organizing, and interpreting information or data. Statistics is a way to take a bunch of data, take a bunch of something that we know, and figure out a way to explain it as a whole, or to interpret it and to organize it. Give us a way to understand something that it is that we're actually looking at. Now, there's two major branches of statistics. There's descriptive statistics and inferential statistics. So descriptive statistics, you just take the root of that word. Descriptive statistics are used to describe the characteristics of a particular data set. So it's a way to describe a data set in a simplified ways that gives an overview of what it is that we're actually looking at. So a collection of data is sometimes called a data set or just data. There's several different examples of descriptive statistics. So the average age of everyone in this class, so the mean age of everyone in our statistics class this semester would be the mean. That would be a descriptive statistic. And let's say the most popular college major at Fresno Pacific University, which is usually psychology, that would be the mode, the most frequently given thing of a data set. So when you think about descriptive statistics, it's anything you use to describe a data set, to give us information about how many males and females, information about where people live, information about whether you're a Democrat or a Republican, those kinds of things. It describes the data set. So here's an example of a descriptive data set. This gives the name of several different persons from a fictitious class, what their major is, and then what their age is. So we could look and find out what's the average age of the persons in this class, what's the highest, and that'd be the mean. The mean is the average number for any particular variable within a data set. And then we could also look at what's called the mode. And the mode is simply what's the most frequently given for any particular variable within a data set. So what's the highest number of people in a particular major? That would be the mode. So once again, descriptive statistics is simply a way to describe a data set. Now, inferential statistics are slightly different because inferential statistics are used to make inferences based on a smaller group of data. By inference, we mean that we're taking a smaller group of data to help us understand or describe a larger data set, or to make inferences about what's going on in that particular data set. There's two basic data sets that we often work with or think about. We have a sample and a population. A sample is a smaller subset of a population. A sample is a smaller subset of a population. A population is the entirety of the particular group of people that we're looking at. So population is all of the occurrences within a certain type of characteristic. So a population number would be all students who currently attend Fresno Pacific University. A sample of that would be if I grabbed, say, 50 different students from that population and created a sample. Now, inferential statistics is when I don't have information in general about the population, but I use the sample that I have to give me information about that population. I make an inference about the population based on the sample that I have. So some examples of this is you find the best treatment for a particular type of disease. One of the diseases, of course, we're working with today would be something like COVID. So I take 150 people, I split them up into groups. With the first group, I give them a sugar pill. With the second pill, I give them a new drug. And if you find a statistically significant difference, you infer that you would find similar results in the population. So if I'm testing this new drug, say for COVID, half the people in my sample get the drug, half of them do not, and then I see, is there any difference between these groups? Meaning, do the persons who receive the drug actually do better with COVID than those people who do not? And if that's the truth, then I make an inference that this is a drug that'd be helpful for the entire population. And that's the inference, going from that small group to the larger group. So, statistics help us to organize information, and then ultimately knowledge of statistics is going to be important in many different fields. If you've been following what's been going on with COVID lately, you'll see that there's a lot of different sites that have all kinds of statistical data about how the spread of COVID is going, how many people have the disease, so on and so forth. And having information about that helps us to understand how the disease spreads, who's most vulnerable to the disease, there are different areas that are doing better or worse with COVID, so on and so forth. So why are you doing statistics? Why should you do statistics? Number one, it does look good on a transcript. Having any type of computational or statistical background is really important. Even if you don't, so for one, if you go on to grad school, you have to have some kind of background within statistics. Whether it's in counseling or any other type of psychological field, statistics and experimental design is a part of it. Even if you want to be a therapist, understanding how to do different types of experiments that look at how effective different sorts of psychological treatment are is a basis for any advanced psychological degree. Also, any kind of business ideologies. Let's say you decide to do something besides psychology after you graduate. Having statistical background is very helpful for whatever field you get into, because statistics helps us look at and get a larger picture of what's going on in something. Whether you're trying to sell something, whether you're trying to help people, whether you're trying to understand what solutions can help in a particular city. Having data-driven answers to questions we have is a general part of the workforce these days. So that's what's so great about this class, is it teaches you how to use that information. And then once you learn how to use R, because R is a free software that you can use anywhere, you can take that skill wherever you are. So it's going to set you apart from other students. If you take the challenge and really learn how to use R and learn statistics, it's going to set you apart from other students. The best students I know, the students that go on and do well, are people who know the basics of the experimental design and know how to use statistics. It's very intellectually challenging, so it's going to train your mind to think like a scientist. It'll make you a better student. give you a great foundation for going on to whatever field you want to go into, helps give you a new perspective. So a lot of times we make a lot of assumptions about different things, and as psychologists especially, we want to test our assumptions. Data allows us to test assumptions, and it gives us an objective measure for what's going on. So if you say that something is true about a population, if you say that so many, there's a certain percentage of people who have to deal with autism, or there's a certain amount of people who have to deal with some kind of other psychological disorder, having the hard data allows us to know what is real and what is mythology when we're talking about different types of psychological functions. And of course, you can also brag about your achievement. And of course, my best students, the students that I think work the hardest, I always brag about them a lot as well. Okay, so a few things to think about when you're using your book and as you learn about statistics. Remember, you're not dumb. You may feel like you don't understand a certain concept at certain times, but you're not. Every semester, I've been teaching statistics for 10 years. Every semester I have students come in that say they don't understand math, they don't like math, they don't like statistics, and they don't want to learn any of it. And a lot of times it's because they feel like they can't do it. You can do statistics. It can be difficult. At times it can be hard, but if you stay focused, if you stay thoughtful, you can do it. How do you know that statistics is hard? It may not be as bad as you think. A lot of people have had other experiences with other classes. They just didn't understand something. I try to slow down as much as I can, especially since we're all online. Set up some appointments with me. Set up some Zoom appointments. I'm going to try to have some study groups going. So there's going to be a way for you to learn in this class. Don't skip any of the lessons. The way we learn, the way that statistics gets learned the best, is kind of a slow progression. We slowly build up our knowledge. And make sure you know how to apply the knowledge that we learn from the class. Learn about how it functions. Learn about how to apply it in other areas. The more application you can find of the things you're learning, it will help with your expanding knowledge of how statistics work. Make sure you form a study group. Find some friends, even if just one other friend. Set up some Zoom or Google Hangouts, whatever you want to do. Hang out and you can do homework together. You can work on some of these problems together, help each other out, test things with each other. It's going to be very helpful in terms of furthering your knowledge with statistics. Make sure you do the exercises at the end of the chapter. Those are going to be basically homework assignments that you'll have most weeks. So make sure you do them. And then once you've done that, even if keep practicing. The more you practice with statistics, understanding the concepts, and the more you practice with learning how to use R, the better you're going to do. R can be a little bit intimidating at first because it's more of a computational language and a code-based language. But actually, once you get the hang of it, it really isn't that bad. And I promise you that I offer as much help as I can with R. You will have the code or the directions for doing all the different examples that I'll be giving in class, so you can go over it yourself. So there's a lot of ways to help you improve what it is that you're doing. Always look for real-world applications. So look for places you can use statistics in your newspapers or your magazines, or just looking at different data in that way. And then, of course, try to have fun. This isn't the funnest subject in the world. I understand that. I try to make jokes. They're usually bad dad jokes. I apologize already for those. But, just do the best that you can. Stick with it, and you'll be good. Here are some of the icons that you'll see within the book itself. The steps icon indicates that a set of steps is coming up and direct you to that particular process. So these icons will help with showing you the steps that you need to complete a particular statistical task. The R icon lets you know that the information focuses on R or RStudio. Um, RStudio is basically an expansion of the R statistical program, and RStudio just adds a lot more helps to looking at statistics. This kind of gives you a difficulty index, so it'll kind of give you a little bit of a forewarning that you may need a little bit more time with a particular chapter. It's not going to be too overly easy. There is a glossary in the back of the book. I would highly recommend going through that glossary as you see different sorts of terms. Remember, bolded terms, and this is really true of any textbook you have, any class you're taking, focus on those bolded terms. The bolded terms, you should know the general definition of them. Each week you're going to be assigned both the lecture, which I'm giving you right now, as well as reading the chapter. The chapter reinforces what it is that you're learning. And you should be reading the chapter alongside of hearing these lectures. And then go back to the glossary, use the bold words, and make sure you understand the different concepts. Real world stats. The book contains several examples of stats that are used in the real world. Typically, it demonstrates how to use a particular method, test, idea, or sorts of statistics using some sort of real-life example. So you can focus on those. You can even look up. It's often related to different psychological papers or different articles from different journals. You can often look up those journal articles, and it'll give you an overview of when that statistics was actually used. Okay, so in summary, hopefully that wasn't too bad. We'll see. Make sure you continue to read, so you should be reading through chapter 1. There will be a quiz at the end of the week over this information. And then let's just take it one chapter at a time. What's nice about this book in comparison to the book I used before is this book goes much slower than the book I used in the past. So just take what we're learning here, sample population, descriptive statistics, inferential statistics. Understand what each of those things mean. Read through those sections in your chapter. Start to get a good understanding of those things. And then you'll be ready for the next chapter, ready to handle the next thing. And then you'll be learning statistics before you know it. All right, so that's the end of this lecture for today. And I will talk to you later.